Hello, my dear ones. Welcome to your own YouTube channel, Vihan Classes. Here we are going to discuss about exercise 6.3 questions that is related to concept of similarity of triangle. Class 10 will solve those questions one by one. Let's start with this question number 1, which includes 6 questions, and all 6 sub questions are pair of triangles where some parameters angle has been given, in some question side has been given, and in some question side and angle both has been given, and we have to decide whether the pair of triangles are similar to each other or not. So that is the first thing. Start with the first question. This question states, what it states nothing. That is a pair of triangle that must be visible to you. This is a pair of triangle where you can see the two triangles are different in size, but their angles are correspondingly equal. If you wish, you can write angle A is equal to angle P, and angle at B formed is equal to angle formed at Q, and angle formed at C is equal to angle formed at R. See, all three angles are equal to all three angles of another triangle. So we can call these two triangles quite simply. Triangle ABC is similar to triangle, and similarity will be written in an order that is according to question. Write the pairs of similar triangles in the symbolic form. So I'm trying to write, and the name of the triangle means the vertices will be taken in order. So if we have taken ABC for first triangle, so we'll take the first letter A is correlated with P. So it will start with P, and for B we'll write Q, and for C we'll write R. And that is as simple as that, very simple criteria. AAA. If all three angles of two triangles are equal, they must be similar to each other. That is as simple as that. ABC and PQR are the two triangles. So I'm trying to relate them. AB is the smallest of all three sides of this triangle, that is 2. So if it will be correspondingly somehow proportionate, it will be correspondingly related to, that side must be the smallest one among all the sides, as this is the smallest in this triangle. So a smallest among all these is QR, all right, and BC is second largest, so it will be correspondingly related to the second largest 5, that is PR, and the largest one in this is AC, so will be correspondingly related to the largest one PQ of the other triangle. So if we try to write ratios of these two sides, AB over QR, that you can say 2 over 4 is half, and the same way it is BC over PR is also 2.5 over 5, that is half, and the third one AC over PQ is 3 over 6, that is also coming to be equal. So we can see here directly, double of 2 is 4, double of 3 is 6, double of 2.5 is 5. So all three sides are proportionate, and we have proved. You need not to prove like this at times. You can mentally do it like, yes, the three sides are proportional. Now we can say, on basis of if three sides are proportional, then it is enough to call them similar by SSS criterion. So I'm writing this two triangle ABC is similar to triangle. How will we correspondingly write AB? For A is the vertex opposite to the side, that is middle size. 2.5 is right in between 2 and 3. So here middle size is this 5, and corresponding vertex will be Q. So this is Q, and for B it is the largest. So for B it will be the largest, opposite to the largest is R, and the remaining one is P. And the similarity criteria that we have applied here is S, and S. All three sides are in equal ratio, or you can say them to be proportionate, and this is enough to call these two triangles similar to each other by SSS. Coming on to the next question, that is question number 3, third of first question. Here we can see there are two triangles LMP and DEF, and we have to check whether they are. So starting with MP, the smallest side of first triangle, if somehow correlated, the correspondence will be with the smallest side, that is DE, and the second largest side is LM for this smaller triangle. And if somehow we can write correspondence, so this is the next big, that is 5, that is EF, and the biggest one is LP of this triangle, so will be correspondingly related to biggest of this, that is DF. And if we somehow try to write the ratios MP over DE, so MP is 2 and DE is 4, it is coming to be half. And for second, LM is to EF, that is 2.7 is to 5. Definitely it is not equal to half. I don't know how much this will be. If 2.5 would have been here, it will be equal to half. So definitely it is not equal to half. And the third side is LP over DF, that is equal to 3 over 6, again half. So two sides are proportionate, but third is not. So we can say MP over DE is not equal to LM over EF, and this much is enough. This much is enough to call these two triangles not similar to each other. So we can write triangle LMP is not at all similar to triangle DEF, and we need not to give any further reason, because two triangles may be similar only if all three sides are proportionate. Pair of sides are correspondingly proportionate to each other. So this third pair of triangle was not, no need to worry. Now taking this fourth one into consideration, I'm trying to write LMN. So starting with LM, this is the bigger side among the two given sides. So correspondingly, they'll be related to QR, that is bigger side of the two. And again, MN, if can be related to PQ only, because MN is smaller and PQ is smaller in this two. Angle M is equal to angle Q that has been given. Let's try to see LM, ratio of the corresponding sides. LM over QR is 5 over 10, and that is half. And again, the same way, MN over PQ is how much? MN is 2.5, and PQ is 5, that is double of it, is half. Again, so the two sides are proportionate and one angle is equal, and this is also we have learned in the similarity criteria of SAS कि अगर दो साइड्स प्रोपोर्शनेट हों और उन्हीं दोनों साइड के बीच का एंगल अगर इक्वल हो तो ये दोनों ट्रायंगल सिमिलर हो सकते हैं, होते हैं, नॉट हो सकते हैं, डेफिनेटली होते हैं. So we'll write triangle LMN similar to triangle, and in place of L, can we write L is opposite to the smaller one, so the smaller one is 5 and opposite to this is R, and M is something where the angle has been formed. So the angle has been formed here at Q, and the last one we can write because there is no more option. So this is the way we can write their similarity correspondence vertex by vertex, and the criteria must be side angle. This is clear to you, and you people keep on liking and sharing If you wish to give some kind of feedback for improvement of presentation, you please write in the comment box. I will try to include that suggestion into my next video. Now, moving ahead to the next question. Two sides and angle has been given. So let's these two sides into consideration. AB, if correlated, then it will be correlated to DF only, because AB is the smaller of the two sides and DF is again the smaller of the two given sides. And BC is the bigger side. So the bigger side in this triangle is EF. And angle at A is equal to angle at F. Yes, two sides and one angle has been taken into consideration. Now let's see whether the sides are proportionate or not. We can see directly this is double of 5, this is double of 6. Even then we are showing by the procedure, that is 2.5 over 5, that is half. And next one, BC over EF is BC over EF is 3 over 6, that is again half. So we see two sides are proportionate and one of the angle is equal. Then we can straight away write this as triangle ABC is similar to triangle. And now be aware, for A, let's guess which angle you will take into consideration, which vertex for A. A is the vertex where the angle has been formed. So here F is a vertex where angle has been formed. Are you looking at it? And then B is between the two sides. So F is between the two sides. F is coming twice. So that is something wrong in this. What is wrong? You can easily guess now. The two sides, including this angle, I mean, this angle has been formed by the two sides that has been provided as information. But here the case is different. The angle is not lying between, the angle is not formed between the two sides. Here the angle is formed between the two sides. So despite of having two sides proportionate and one of the angle equal to each other, we should look at the correspondence. The correspondence is not there. Correspondence of angle and sides are missing. So we can say it is not SAS. Angle must be lying between two sides. Here angle is between the two sides, but here the case is different. By SAS, we cannot call these two triangles similar to each other. All right, moving on to the last one of this question. Here the two triangles has been given as it has been given. You can see two of the angles. If two of the angles are equal, then AA is also a valid criteria. If two of angles are equal, then third will have to equal. But the two angles are not equal at all. And there is no side also given. So let's find out the third angle first. So if we'll apply the angle sum property, the third angle will automatically come to be 180. That is supplement of 70 plus 80. That is 30 degrees. And if we try to find out this angle, that is supplement of the two angles 80 plus 30, and that is also equal to 70 degree. Now if we'll try to look at it from a different perspective, the angle formed here is 30 degrees and angle formed here is 70 degrees. And now you can see all the three angles of two triangles are equal. Writing them, triangle DEF is similar to triangle. Let's see, for D we'll take P, because 70 degrees is formed here at D and P, and for E it will be Q, and for F it will be R. And what criteria we have applied? We have applied AAA. Thank you very much. Keep